Metal inert gas welding, or MIG welding, is based on the electric arc welding process, where completion of an electric circuit between positive and negative poles creates an electric arc which generates tremendous heat, permitting the fusion welding of metals to take place. The main difference between MIG welding and manual arc welding is that the MIG process is carried out using a continuous wire electrode, which is fed through the welding gun to the work at a preset controlled speed. At the same time, a shielding gas is fed through the gun onto the weld zone to prevent contamination from the surrounding atmosphere. By varying the types of shielding gas and electrode wire size, a wide range of metals may be welded using the MIG process. MIG welding may also be referred to as gas metal arc welding, or GMAW. MIG welding has many advantages when compared to other welding processes. It's faster than other welding methods and therefore generates less heat and distortion to the weld metal. The MIG process can weld very thin, high-strength steels. No flux is required and there's no slag to remove from the weld area. The process is extremely flexible and can be used in all positions by changing the mode of metal transfer. The welder has a much clearer view of the weld pool. Because of the continuous electrode, longer uninterrupted welds can be produced. A specially designed welding machine is used for MIG welding. The welding machine has a constant voltage power output. This means that the output voltage will remain consistent regardless of the welding current.
A wire feed control unit enables the electrode wire to be fed as required from the spool. It is the rate at which the wire is fed through the torch which controls the welding current. Therefore, the faster the wire feed, the higher the welding current. Various cables extend from the welding machine and wire feed unit. These include the mains cable, which supplies power to the welding machine, flexible conduit, which supplies current, wire and gas to the welding gun, and the work or return cable, which is clamped to the work or workbench.
The work cable is required to complete the electric circuit.
The gas cylinder has a combination regulator and flow meter. The shielding gas is carried from the cylinder via the wire feed control unit to the welding gun. The gas cylinder must be held in place with a safety chain.
The welding cable contains the electrode wire, welding power cable, shielding gas hose and start-stop control wires. The cable is connected to the welding gun. The welding gun brings together power, gas and wire and directs these elements to the weld point. The trigger activates power, wire feed and gas flow. The first thing to consider is the safety of your work environment.
First, clear all rubbish and potential fire hazards from the area. Your work area must be well ventilated. If adequate ventilation is not available, fume extractors should be used. If you are not working in an established welding bay, portable screens should be placed around your immediate work area to protect others from harmful ultraviolet and infrared rays. Always check that all cables and connections are in good order.
A commitment to safety in MIG welding means you must always use the correct protective clothing and equipment.
Clothing must include overalls and safety boots, an apron and protective gloves. Ultraviolet and infrared rays emitted from the electric arc can be extremely dangerous to your eyes and skin if they are unprotected. A welding shield or helmet fitted with the correct filter is absolutely essential. Whenever wire brushing metal to be welded, safety glasses should be worn. The welding machine has a voltage control marked in equally spaced graduations, which controls output voltage. The wire speed dial controls the rate at which the wire is fed to the gun and the amperage or current level. Some machines have a weld timer, which is used for spot welding. When spot welding, the timer adjusts the duration of the weld time for each spot weld between pauses. Connected at the top of the gas cylinder is a gas regulator and flow meter, which governs the flow rate of gas leaving the cylinder. The flow rate is set by adjusting this control.
Flow rates vary depending on the thickness of the weld material and design of the joint. Before we set up to weld, it's important to understand the meaning of some terms and methods relating to MIG welding.
At the end of the welding gun is the gas nozzle, which encases the contact tip through which the electrode wire passes. The distance from the end of the gas nozzle to the end of the electrode wire is called the stick-out. The length of the arc, which is determined by the voltage level, is measured between the end of the electrode wire and the workpiece.
When MIG welding, different methods are used to deposit the electrode wire onto the weld surface. The two most common methods are spray transfer and short arc transfer, sometimes called dip transfer. When using the spray transfer method, fine particles of electrode wire are transferred rapidly across the arc to the weld pool.
When using this method, high voltage and current are required. The spray transfer method allows high-speed welding and results in a good weld appearance, but welding out of normal position is not recommended.
The short arc or dip transfer method requires low current and voltage settings to produce a short-circuiting arc.
The short circuit occurs when the electrode wire actually dips into the weld pool. When the electrode wire has melted off, it again dips into the weld pool, recreating the short circuit. The dipping process can occur up to 200 times per second. This method creates low heat input to the weld area, which is ideal for welding thin metals. Because this method creates a relatively cool weld pool which solidifies rapidly, it is widely used for out-of-position welding.
The mode of transfer used is dependent on the amperage setting, which in turn is determined by wire feed speed. There are many different types and models of MIG welding machines. Even though the principles of MIG welding remain the same, the dial settings that are used in this program apply to the type of welding unit that was chosen. As your welding unit may differ, make sure you consult your operating manual or trade teacher. The type of gas required for MIG welding is determined by the type of material you are welding. For example, the shielding gas required for welding aluminium will be different to that required when welding steel. The gas required for welding mild steel is a mixture of argon and carbon dioxide. Make absolutely sure that you select the appropriate shielding gas.
Wire brush the metal to be welded to remove any rust, grease or paint. Open the gas cylinder. Switch the welding machine on. Set the voltage. We will use a wire thickness of 0.9 millimetres. Adjust the wire speed appropriately. Using the gas flow meter, adjust the flow rate to 12 litres per minute. To check the flow rate, depress the trigger on the welding gun. Trim the excess electrode wire to a distance of 10 millimetres from the contact tip. When welding, the stick-out length will then adjust depending on the wire feed setting. It is important to remember that the longer the stick-out length, the less arc energy occurs.
At this point, welding can commence. Now, keep in mind that fine-tuning of the controls may be required to optimise the welding process.
First of all, make sure you have your shield or helmet in position. Holding the welding gun at an angle of 65 to 70 degrees in the intended direction of welding, with the nozzle approximately 10 millimetres away from the workpiece, depress the trigger. The wire and gas will flow and the arc will be established. After the arc has been established, move the gun forward in the forehand direction. If you're right-handed, you should move the gun from right to left to ensure that you have a good view of the weld pool. Of course, if you're left-handed, the opposite applies. Make sure you keep the nozzle close enough to the work to maintain the arc.
Excessive stick-out reduces the effect of the shielding gas and may cause porosity in the weld joint.
If all settings are correctly adjusted and a good arc length is established, you will hear a rapid crackling sound. To end the weld, steady the welding gun and release the trigger. Check the weld. It should have an even shape, size and ripple.
It is important to be aware of the various weld faults and problems that can occur and how to overcome them.
To eliminate the build-up of weld spatter which occurs on the inside of the gas nozzle, an anti-spatter spray can be used. This will ensure an even gas flow around the weld area. Stubbing occurs when the electrode wire sticks to the contact tip. This is caused by selecting a voltage setting which is too low. A burn-through is exactly as it sounds. A hole in the weld bead occurs. This may be the result of insufficient plate edge preparation, amperage too high, or too slow a welding speed. Incomplete fill, on the other hand, results when the weld metal has not completely filled the joint between the parent metals. Undercutting occurs as an irregular groove on the side of the weld. This can be caused by an incorrect gun angle or an amperage setting which is too high. Porosity occurs when tiny air bubbles are trapped in the weld. This is generally caused by insufficient gas flow. Excessive spatter around the weld area may occur for a number of different reasons, such as use of wrong gas type or the voltage selection being too high.
Because all metals expand when heated and contract when cooling, distortion of the metal can occur.
To control distortion, tack welds may be used at intervals along the intended weld joint. The spacing between tacks is largely dependent upon the thickness and length of the metal to be welded. The fillet weld, or T-joint, is achieved by setting the two pieces of plate at right angles to one another. After tacking, position the welding gun at an angle of 45 degrees. Commence the weld run using the spray transfer method to ensure sound penetration at the weld root. It is important that the weld is of equal size on each piece of parent metal.
When using thicker pieces of plate, welding can be accomplished by using multiple passes, or weld runs. The number of weld runs is determined by the thickness of the plate and the wire diameter.
The technique is the same when depositing the first weld bead, which we call the root run. Check the weld, then deposit the second run. The gun angle should be approximately 70 degrees from the horizontal. In the second and subsequent runs, the short arc or dip transfer method is used. In this case, we will use a circular motion to spread the weld metal. The circular motion will help to flatten the face of the weld. The weld metal should be placed along the lower part of the first run and almost cover it. In the third run, the angle should be approximately 45 degrees. It should extend from the surface of the vertical parent metal to the upper edge of the second run. This will cover the remainder of the exposed root run.
The single V-butt is a very common weld. Its chief asset is its tremendous strength.
Preparation involves the beveling of the edges to a 35-degree angle. A landing of approximately 2 millimeters is required. Prior to tacking, align the plates with a gap similar to the landing size. After tacking, angle the gun at approximately 45 degrees in the direction of welding and deposit the root run using the short arc transfer mode. Subsequent runs are deposited using the circular technique until the weld is completed. The final runs are called capping runs. To seal the joint, deposit a weld bead along the bottom of the root weld. The two pieces of plate should be placed approximately 1.5 millimeters apart to ensure penetration. Prior to welding, tack welds spaced at appropriate intervals should be used to maintain alignment. Small tacks should be used to ensure that they do not affect the appearance of the weld. Using the short arc transfer method and a gun angle of approximately 45 degrees in the direction of travel, commence welding. Move along the line of the weld. When you have completed the weld, break the arc cleanly. Check the work to ensure adequate penetration has taken place.
When welding in the side horizontal position, a similar welding sequence is followed for the single V-butt weld in the flat position.
The electrode wire should be at right angles to the weld joint. Assuming you're right-handed, begin welding at the right-hand end of the joint. Adjust the rate of travel to ensure sufficient fusion without over-penetration. But given the horizontal position of the plates, the capping runs are deposited as small weld beads called stringer beads to overcome the gravitational effect. To hold the plates in position, tack at either end. Then, using the short arc transfer method, commence welding at the bottom end of the welded joint. To ensure root penetration and a flat weld face, the welding gun should be moved in a triangular motion whilst moving up the weld joint. The second run uses a weaving technique where the weld gun is moved from side to side up the weld joint. It is essential to pause at either side of the weld joint to avoid undercutting. Check the weld to ensure undercutting has not occurred.
At the completion of your work session, it's important to ensure that you have closed down the welding unit correctly.
Switch off the mains power source. Close the valve on the gas cylinder. Place the welding cable and torch on or near the unit.
Hopefully this video has given you a basic understanding of the principles, processes and methods relating to MIG welding. If you encounter any difficulties or you're uncertain about anything to do with MIG welding, please don't hesitate to talk to your work supervisor or trade teacher. And remember, safety comes first.